All right, today we're diving into something called OpenClaw. And let's be super clear right from the start. This isn't just another app or some simple chatbot wrapper. No, the way it's being described is as a whole new category of software, a true operating system for AI agents. So we're going to break down what that actually means, from its core architecture all the way to the pretty serious security questions it brings up.
And the hype around this thing, it is real. I mean, when you have someone like Andrej Karpathy, a founding member of OpenAI, former director of AI at Tesla, when he says something like this, we're talking about more than just a small step forward. This quote just perfectly captures that feeling that we're on the edge of something totally new, moving from AI that just talks to AI that actually does things.
Okay, so here's the game plan for our tour. First, we'll nail down what it even means to be an operating system for AI. Then we'll explore the core components. We've got the gateway, which is kind of like the system's kernel, the agent runtime, that's the brain, and then we'll get into the super important difference between tools and skills. Think of them as the hands. After that, we'll follow a single message from start to finish. And finally, we'll tackle the huge security challenges that come with all this power.
So what does it really mean to be an OS for AI? At its heart, this is all about a massive shift in how we think about architecture. We're graduating from the simple back-and-forth chatbots we all know, and we're stepping into the world of persistent agents that have memory and can actually take action for us.
Okay, here's the big idea. OpenClaw isn't the AI model itself. It's the structured world that the model gets to live inside. Think of it like this. The large language model, that's the raw brainpower, right? The intelligence. But OpenClaw provides the operating system, the whole body, the nervous system, the file system, memory, I/O, everything that intelligence needs to actually do stuff in a controlled and useful way.
And the way they pull this off is with a classic hub-and-spoke architecture. You've got one single central process, they call it the gateway, and that's the hub. Then all your different ways of talking to it, whether it's WhatsApp or iMessage or a command line, those are the spokes. This design is what makes sure you have just one single assistant with the persistent memory. So you can literally start a chat on your phone while you're out and then pick it up right where you left off on your computer's command line when you get home. It's all the same agent, accessible from anywhere.
So let's zoom in on that hub, the gateway. This thing is the absolute heart of OpenClaw. It's acting just like the kernel of a traditional operating system, or you could even think of it as the central nervous system. It is the single source of truth for everything that happens. So, what is this thing under the hood? Well, technically, it's a WebSocket server that's designed to run forever, basically. It's always on, holding open those connections to WhatsApp, Telegram, and whatever else you've hooked up. And this is super important. You only run one gateway on a machine. Why? Because it prevents all sorts of chaos, like having two different processes trying to log into your WhatsApp account at the same time. And look at everything this gateway is responsible for. It's not just some simple message passer. It's holding all those outside connections steady. It serves up a strictly typed API, which means it validates every single piece of data coming in against a schema, so no malformed junk ever gets to the agent's brain. It's constantly broadcasting system-wide events about what the agent is doing, who's online, and the system's health. And on top of all that, it handles security, like device pairing and authentication. It really is the tough, secure front door for the whole system. Okay, so if the gateway is a kernel, the central nervous system, then the agent runtime, well, that's the brain. This is where all the magic happens. The thinking, the planning, the doing. This is the cognitive center of the whole operation. So for every single thing you say to it, the runtime goes through this lightning-fast four-step process. First, it snaps together all the necessary context. Then it invokes the language model, sending that context over. As the model thinks and responds, the runtime is watching, and it intercepts any requests to use a tool, and then it executes it. And finally, it saves everything from that interaction back to disk, your message, the model's chain of thought, what the tools did, and its final reply.
And this right here, this is one of the coolest parts. This is how the agent literally builds its thought process for every single response. It's not one giant static prompt. No way. For each turn, it dynamically pieces together a new prompt. It grabs its core operating instructions from one file, its personality and tone from another, and even your personal notes on how to use tools from a third file. Then, it bolts on the recent conversation history, pulls in relevant memories, and finally, it tacks on an auto-generated list of every tool it's allowed to use at that moment. It's an incredibly flexible and powerful system.
All right, let's talk about a concept that is absolutely critical to understanding how OpenClaw actually gets things done in the real world. We have to draw a clear line between two things: tools and skills. It's all about the difference between what an agent can physically do and how it knows what to do. And the analogy here is just perfect. Tools are the agent's organs, and skills are its textbooks. Tools are the raw physical capabilities you give it, like the ability to execute a shell command, control a web browser, or write to a file. They're the fundamental body parts. But a skill is the knowledge, the textbook, that teaches the agent how to use those tools together to pull off a complex task. For example, a GitHub skill is a textbook that explains how to use the exec and write tools to manage a code repository. And here's the kicker. A skill is totally useless if the tools it needs aren't enabled. The agent can have the textbook, but it's worthless if it doesn't have the organs.
Okay, let's put all these pieces together now. We're going to follow one single message, let's say from your WhatsApp, on its complete journey through the entire OpenClaw system, all the way to a finished task and a reply back to your phone.
It all starts with Step 1, ingestion. Bam, the message hits the WhatsApp adapter. Step 2, access control. The gateway acts like a bouncer. Are you on the list? Yes? Okay, you're in. Step 3, context assembly. The agent runtime, the brain, pulls together conversation history and relevant memories to build that dynamic prompt we talked about. Step 4, model invocation. That all context gets streamed to the LLM. Then, as the model responds with its plan, we hit Step 5, tool execution. The runtime intercepts any tool calls and runs them. Maybe it reads a file or does a web search. And finally, Step 6, response delivery. The final, polished answer is sent back through the gateway, out the WhatsApp adapter, and right back to your device. It's a clean, 6-step flow.
So you can see how unbelievably powerful this architecture is. But, and this is a huge but, when you give an AI autonomous access to your file system, to your shell, basically the keys to your digital kingdom, you are opening up a security Pandora's box. With this kind of power comes a truly massive attack surface.
And this quote from the security research firm Pentalegend just nails it. We have to totally change how we think about this stuff. Traditional security is built for predictable, deterministic systems. But here, we're not just locking down an app anymore. We're trying to secure a semi-autonomous entity that thinks in probabilities. Its behavior isn't always predictable, and that changes the entire game.
In fact, Pentalegend came up with a name for this new kind of architecture, the Privileged Automation Bus. And what that really means is you're hooking up a fuzzy, creative, probabilistic brain, the LLM, directly to a super-literal, rigid, deterministic environment, your computer's operating system. This hybrid model, where the ambiguity of human language can trigger unforgiving system commands, creates entirely new ways for things to go wrong.
And some research from SemGrip gives us these 4 first principles that really explain why this is so dang hard. First, that clean line we used to have between data and code, it's gone. The LLM reads data from a website and produces code in the form of a tool call. The boundary is a blur. Second, you can't just trust the LLM's output because it's internal. It could have been tricked by its input. Third, determinism is gone. You can't write a test for every possible thing it might do. And finally, the blast radius scales with capability. The more tools you give the agent to make it useful, the more catastrophic a compromise becomes.
So all of this leaves us with a really big, kind of scary question. We've built this incredible new type of system. The power is obvious. The potential is undeniable. But as we step into this future where our software is semi-autonomous, how do we, as engineers, as users, build the right guardrails? How do we make sure these powerful new assistants are our partners, not our problems? Honestly, that's the billion-dollar question we all have to figure out.